Okay. Hey, we're going to get rolling here. Thanks everybody for joining us for the latest Sketch webinar. We've got a special treat for you today, coming to you live from beautiful downtown Baldwin, Missouri. I'm here to introduce our presenters today. Matt House is our in-house training solutions lead. Ryan Jensen is our in-house cloud management service lead. And today they're going to talk to us about CI/CD pipelines and how product owners can leverage that pipeline to get products into production faster. Excited to hear what Matt and Ryan have to say today. So take it away.
All right, good morning. Welcome to the latest Sketch webinar. We've spent a lot of time lately talking about product development. And so we wanted to take some time to talk about the key interaction between product development and how our products are actually put forth into production through a mechanism called a CI/CD pipeline. And so a CI/CD pipeline can bring enormous value to how you deliver your products. And by the end of this, we'll have talked about 3 specific things that a product owner can do to leverage the value of the CI/CD pipeline. So we are going to be doing a Q&A section later on. So if anybody wants to jump in at slido.com with the number 917643 or just scan the QR code, that should take you into our Q&A section. And so we'll be kind of peeking at that throughout the presentation, but we're probably going to be fielding a lot of those once we get closer toward the end of the presentation.
And we'll provide that link again at the end as well for you to jump in.
Yep. All right, so let's get into it. Let's talk about the concept of battling uncertainty. So one of the things that we have to realize is that when we go to build something, we don't know exactly what value it's going to bring. We need to accept that whenever we build a feature, we don't know exactly what it's going to do and what value it's going to bring to us at the end of the day. Think back to when you were a kid and you had to do science fair projects. You built a hypothesis, you isolated variables and constraints, and you ran tests. This is what we want to be able to do with our feature delivery. We want to be able to look at these things as little mini science fair projects, and that we've got our hypothesis of, we believe if we deliver this, it's going to bring X value, or it's going to do this, and we put some sort of a measurable signal behind it to be able to figure out whether it's doing that or not. While many of you agree with this probably agree with this statement, I am going to challenge you and ask you, when was the last time that you went to validate whether if what you built actually worked and brought the value that it wanted to? If you thought something might reduce cycle time on a process, did you actually measure it and see? These are the things that we want to be doing whenever we develop anything new, because we need to accept that we don't always know what's going to happen. And iterating on your solutions and testing your hypothesis, we know that's expensive. So we need to find ways to do it better, faster, and cheaper. So I'm going to go into professor mode on you and get a little academic here for a sec. These are the 3 ways that were developed by Gene Kim, and things that he really used, weighed heavily on when he was writing the DevOps handbook with Jez Humboldt. And that when he looks at these 3 ways, and these 3 ways are about enabling flow, getting fast feedback, and being able to create a learning culture and a culture of experimentation, and being able to iterate on solutions. So he developed this model that at least me personally, I kind of really lean on when I'm talking about how we develop our products and how we start to build out the flow of value within our organizations. And to kind of simplify that, we'll take another look at it here. And so flow is all about getting features into production faster. Feedback is, once we get that feature into production, we need to get fast feedback on whether or not that's delivering the value that we think it will or not. And then learning, we want to leverage that speed to determine which features to put into production next. So now that we've got the feature in, we're getting feedback on it, now we're turning ourselves into a learning culture. And when a lot of people look at some of the larger tech companies, like your FANG ones, your Facebook, your Amazon, Google, that a lot of them say, oh, they're great because they've got great tech. but really what makes them great is that they're great learners and that they understand that they don't always have the right answers. So they're always trying new things out. They're always pushing new things to production and trying to get the right feedback to be able to determine whether they're on the right track and building the right thing or not. And you can't get to this world of fast feedback and learning unless you optimize the flow of features into production. So now it's time to learn how to create that fast flow through a CI/CD pipeline.
So thanks, Matt. I'm going to take this part. So yeah, what we need to do to get that quick feedback is leverage a CI/CD pipeline. Throughout the next couple moments here of this presentation, we are going to oversimplify things. We know this isn't a very super high-tech audience, so we're going to give you a high-level overview of what CI/CD is, what it stands for, and what it can bring you. First of all, what is CI/CD? It's one of those buzzwords that's out there that you hear in lots of articles and blogs throughout all the tech industry, but it's not just a buzzword. It actually is a thing that if you aren't already using it, hopefully your team members are asking you for time to implement it. So to start off, CI stands for continuous integration. More likely than not, your team consists of multiple developers building several features simultaneously. Continuous integration is the process of taking all of their work that they're doing and cohesively merging it all together into a single application that can be deployed to production for your end users to get their hands on and use it and provide you that quick feedback that Matt was just talking about. So that brings us to the next one, getting it out there in the end user's hands. So CD stands for continuous delivery. It's also often referred to as continuous deployment. They're kind of used interchangeably sometimes, although technically they are two very different and distinct things. Starting with the continuous deployment aspect of things, this refers to the actual act of getting the latest feature set deployed to production. Continuous deployment, deploying to production. But just because something's deployed to production does not necessarily mean that it's usable, at least not yet, not right off the bat. Continuous delivery is the other part of that. This refers to the act of releasing or enabling that feature set that's been deployed to production. So the distinction here is that rather than a several hour long deployment at 2 a.m., you can do a several hour midday deployment during regular business hours without any user impact, followed by maybe a 5-minute or so late night delivery when those new features are actually released into the production environment. This is certainly one thing that results in happier teams and helps boost morale. Happier teams equals more productive teams. That's probably as deep as I'm going to go on what CI and CD are. I warned you it was going to be oversimplified. For the rest of the talk, though, suffice it to say that CD, when we talk about the CI/CD pipeline, CD just generally refers to getting your hypothesis, as Matt was talking about, out there into the wild for your end users to get their hands on and try it out. So before we jump into the CI/CD pipeline a little bit, where does your app come from? How does it get from an idea into the production world? The way we want to do that is by leveraging CI/CD pipelines. A CI/CD pipeline is an automated version of all the steps required during this continuous integration and continuous delivery process. But what are those steps exactly? That's what we're going to jump into in this slide here. How does your experiment go from a hypothesis to a deployed feature that you can start getting feedback on from your end users? This diagram shows a lot of things that typically need to take place throughout the entire process. The spot over here on the left hand that's circled in blue, this is generally referred to the continuous integration phase of not just the pipeline, but your delivery process in general, of how you get it from hypothesis to production. The next step in this pipeline or process is this orange area here. This is generally referred to the continuous integration, and there's a little bit of overlap, which is why we see these two circles intersecting. So it's not just the continuous integration, continuous deployment. It's a little bit of both, and I'll talk about a little bit more of this overlap in just a second, but Seeing some more overlap here on the far right-hand side, this is the continuous deployment / continuous delivery phase of all of this. The reason why they're kind of blurry and why there's certain overlaps here, it depends on the maturity of your delivery team and other nuances of your application. But this diagram generally serves as a pretty good guide for the purpose of the conversation we're having right now. So your hypothesis journey begins in your developer's hands. They look over your requirements and make some changes over on the left-hand side here and at the early phases of continuous integration. As they test out the changes that they're making to the application and merge them in to the core application, if all looks good. From this point, this is where the application gets compiled or built and then deployed into a lower QA kind of environment. Maybe you guys have something prior to QA, whether it's a sandbox or integration environment. Regardless of what it is, the application is getting deployed somewhere for you and your team and anybody else to test it out before it's getting into that production world. From this particular environment, in the case we've got here in the diagram, it's referring it to the QA environment. We're going to have the QA team test the application. And so that's represented by these green steps in the process here. So the QA team, they're going to work their magic, creating some test cases, running those tests against both the new features that were just released, as well as the pre-existing functionality of your application. This ensures compatibility between the end user's current expectations and what's about to be changed. Last thing you want is to deploy something, some new changes that break the way things already work in the application. So that's one of the things that QA is definitely searching out to make sure is not impacted by merging these different feature sets all together into one application code stream. So the efforts that are involved by this QA team, it may or may not include some sort of quality scan, which you also see here, and that might include something along the lines of load or performance testing. Now, most of the time, large enterprises have security teams as well that ought to have a say in whether your application is safe enough to be deployed. If it's determined that there's undue risk from some security hole in the latest version of the application, it only makes sense that this go back to the very beginning to the far left and get back in the developer's hands for them to fine tune it and work out any security issues that are there and solidify the application. So after we're done with all those initial steps, the next phase is bringing your application in front of the change approval board. In their hands, they're going to review a checklist of things and they'll either deny it or approve it. And if they happen to sign off on it, then it's going to finally end up in the hands of maybe your database administrators and ops teams for deployment to your final destination. If we take a little bit of a deeper look at some of these steps that I was just talking about, we can see several spots along the way that can be time drags for getting your hypothesis out there. You'll note that most, if not all of these points that are highlighted by these black arrows involve some sort of work from members outside your immediate delivery team. This is probably a good moment to pause for just a sec. I want you to think about what areas in this diagram affect your deployment timelines. Do you have to wait for approval from a change approval board? Do you have to coordinate deployment schedules with ops teams well in advance? How long do some of these processes take you and your delivery team? Do you have to wait for manual deployments, either to QA or production, whether that be maybe from your developers, like I was talking about? Towards the left-hand side under this first black arrow, there's a deploy to QA environment phase. And I know a lot of times that's generally performed by the development team. So if your developers are doing this, how long did this part take? How long is it taking your developers away from working on your next hypothesis? Think about that. If you add up all the time that your developers spend deploying to these lower environments, now think about how many more experiments you could have released using that amount of time that was wasted deploying to the lower environments. How much more value, think ROI here, could you have delivered if this happened automatically rather than taking a developer away to manually launch these feature sets into the lower environments. So now that we've covered the general steps needed to convert your hypothesis to a reality, let's talk about how a pipeline can help. Hopefully you're already starting to see how. So on this next slide, we're going to change some of those phases from the previous slide where maybe the QA team was involved here, we had security. We're going to start automating some of these because if you remember, as I was talking, a CI/CD pipeline is an automated version of all these steps during the continuous integration and continuous delivery process. Let's look at some benefits of automating some of these things, starting at the far left in the continuous integration section. If you just had one developer working on your delivery team, things would be obviously super simple for the continuous integration phase. One developer doesn't really need to merge anything. They're just working directly in the code base. Chances are, though, you've got more than one. When working with teams of just a couple to even hundreds of developers, successful integration is vitally important. Automated tests and test-driven development can springboard you into more successful integrations as features are merged together into single application. And what's more, executing automated tests is one thing CI/CD pipelines do best. So after automating your application build or compilation phase, getting the functionality verified by virtue of these automated tests is next. You'll run things like unit tests, you'll run some integration tests, you'll even have some end-to-end tests, which hopefully these are also automated. There's definitely all sorts of tools and ways out there nowadays to accomplish this. There's things like Selenium, Mercurial, Cypress, there's JMeter, Postman, a whole bunch of things that can automate the typical activities that your end users do while they are interacting with your application. And because these tools offer an automated way to do this, they're a perfect candidate to integrate into the pipeline and keep your delivery team focused on more of your experiments rather than constantly, repeatedly spinning their wheels and running the same old, does the login page still work test? If your delivery teams have to manually test that login page every time they build a new feature, something ain't right. So next on our list here are the quality and security scans. So on the previous slide, we were talking about maybe that's something that the QA team performs and the security team performs. There are, though, automated tools for these as well. And since they're automated, again, they can be added and integrated with the pipeline. Some tools that can help with things like this include SonarQube, Veracode, Snike, and Burp Suite. Yes, Burp Suite. One thing I want to mention about quality scans, though, before we move on, is that they truly ensure that the underlying code of your product is solid, that it's stable. And I know this is probably stupid to say because it's right here on the screen. It's called quality scan, but that is the true thing and true nature of what it does. It is ensuring the quality of your code, the quality of your application. If it doesn't meet some of your guidelines as to what quality is, this pipeline is not going to let it get past that quality scan phase. If the automated scan you're running says, nope, this isn't worth putting in front of the end users, this pipeline is going to reject it and throw it right back to the developers for them to make enhancements, improve the quality, and get it past these automated tests that happen in the quality scan phase. Now, if we jump ahead to the deployment section, the red section over on the far right-hand side, but I actually want to start at the furthest right part and talk about the deployment step in this continuous deployment delivery phase. What are some of your deployment steps that you have within your organization? What things are currently done manually, and why, more importantly, are they done manually? I'm going to get into a little anecdote here just for a moment to talk about some manual steps that I've encountered. And hopefully through this anecdote, you'll realize maybe a different way of looking at things through a different set of eyes to get past some of these manual hurdles that maybe your team's encountering right now. So there was one team that I was helping out once where their deployment process to QA took 30 minutes, and that was if everything went according to plan and went smoothly. The process was full of all sorts of manual commands that they had to type in the command line. And as such, there's always room for error for you to fat finger something and screw it up. And if that ever happened, if you fat fingered it or messed one of these commands up along the way, you're going to have to start this whole process all the way back over from the very beginning, from the start. And one of the reasons why this was all manual is the team that I was working with, they were so hung up on the fact that during this process, they believed they had to use a specific set of FTP software to transfer the files to the deployment server that they would then remote into using SSH and move the files around on the server after it was FTP'd in. But they were so hung up on the fact that we have to use this FTP software to do this step. Now, without getting too technical, SSH and FTP share a similar protocol. If the server you're putting files on has SSH, just use that to copy the files. There's no need at all for this extra FTP software step. So the point I'm trying to make here is getting a different perspective or a different set of eyes looking at some of your processes, especially the manual parts that you firmly believe have to be there for whatever reason. Have somebody else take a look at it and give you some feedback on maybe a creative solution or something outside the box that can help you automate it. Chances are you can probably automate anything at all within your deployment process. Anything a human can do, a computer can do. If a human can do something on a computer, there's a really good chance that it can be automated. Let's move on because we're getting a little shorter on time here. But so talking about the database management step within this, the continuous deployment delivery phase, how long do you spend waiting for your DBAs to help with the database portion of the deployment? How overworked are your DBAs? A lot of places I've been, the database administrators are often stressed out trying to solve all the problems of the world. Last thing they want to do after a hard day of that is help you deploy your app at 2 a.m. But guess what though? There's an app for that too. There's lots of tools for helping with database management deployments and automating database schema changes. There's things like Liquidbase, Flyway, or DBMate, and these things help your developers integrate these changes as part of the code base, way back over on the left-hand portion, even prior to the continuous integration. So having these changes in the code base helps automate and get those the changes deployed as part of your pipeline and really expedite getting any database things whatsoever past your database administrators. So a huge benefit for that though, better still, is that it offloads some of the burden that the DBAs are constantly dealing with all the time. And it enables the DBAs to spend more time monitoring and tuning the performance of your database, which in the end is going to result in a better end user experience for your app. So the last thing on this screen that I'm going to start talking about is the change approval board. But first, a word from our sponsors. There is a better way for dealing with change approval boards. Change approval boards, change approvals by an external body has no correlation to increased stability or a reduction in change fail rate. What does a change approval board actually do? Did they help develop the code? Did they help test it out in QA or UAT? Are they actually sitting with your developers and the rest of your team on a daily basis, understanding what it is that the change is for and what your application does? Are they the ones that are making sure your application's bug-free or preventing production downtimes? On the stack of requests that constantly come across their desks for review, do they even know what your change is all about? Let's look at the next statement on the slide. Studies show that external approvals were negatively correlated to lead time and recovery time. In all of my experiences with change review boards, it's that they are constantly comprised of part-time employees. Part-time in the sense that they usually consist of VPs and or directors, people that already have a lot on their plate And now we're asking them to attend a committee meeting to review the changes that we're putting forth that they don't even know the context of. How often do your change review boards meet? That's something that you ought to think about. I've seen several times where the answer to that question is once a month. Most likely because since they're VPs and directors, how in the world can they afford any more time than attending these meetings once a month? If their meetings are as frequent as that, then that is as often as you're going to be able to test your new hypotheses. Worse still is if your users encounter a nasty bug in production and your fix has to wait until the next meeting of the board for approval. That's going to take forever to get that change out there, or rather the fix in this case. Your end users might be stuck using a crummy, buggy application for that whole amount of time. So a bigger question is, what does a change approval board do anyway? Do these part-time approvers truly grasp the context of your change and the implications of approving or denying your request? And not just your request, but the 100 to 1,000 other requests that they need to look at during this session that they have once a month? Probably not. It's more likely they're just ensuring that you have checked off each item on their form. Is there someone that reviewed the code? Did QA look at it? Did the security team scan it? Did the product owner actually request this change? Things of that nature is probably what you would commonly see on their approval forms. So what about all the stuff we just talked about in the last couple of the slides? Surely I didn't just talk about pipelines because I'm trying out new material to pick someone up at a bar. That pipeline we discussed, it ran tests, it scanned for quality, it even scanned for security. What's more, if it failed at any of those points, it stops and won't go any further, as I was mentioning earlier. It sounds to me like that pipeline is doing a lot of the job that the change approval board is there and they're asking for. The pipeline's doing it already. So this last bullet point on the screen, Sketch recommends a lightweight process anchored by peer reviews and a deployment pipeline that can detect and reject bad changes. Our pipeline has automated a lot of things, but is the QA team approving changes like the CAB demands? Is the security team? We might not be in the clear just yet. We're automating some of these things, but if we're doing it as our delivery team ourselves, I can't in good conscience say that, yes, the QA team is the one that approved it, or the security team is the one that said, yep, this thing meets all of our standards. So that brings us to the next topic of shifting left. Shifting left is the notion of taking some of these things that happen later throughout your deployment and delivery process and moving them as far right as possible into the developer's hands. There are plenty of things that we might do before shifting some of these things to the left that might give us a false sense of hope and trigger us to have a false start in terms of getting our application deployed out there. So we might or rather you might as product owner come up with a great idea, come up with this hypothesis and plan out an experiment that then gets in the hands of your delivery team to where they build it, they test it, they get it in front of you in the lower environments, you get all excited, you're like, yes, this is exactly what I want. We need to get this out there as soon as possible. And then as you get ready to deploy it, all of a sudden you realize, well, shoot, the security team just shot us down because they're super overbooked. They can't look at this thing for another 2 weeks. Or worse yet, let's say they do start taking a look at it and they don't approve it because they find flaws and it has to go all the way back to the beginning, like we were talking about earlier. Developers are going to have to patch things, make changes, run it through the security scan again, and then you're back in their queue one more time, which is going to delay it even further. So what are some things that you might be able to do to move things like security further to the left? Well, fortunately, if you guys are already doing things like containerization or containerizing your application, there's great ways you can have your security team have their say in this whole process before developers even make the single code change at all to your application. security teams can build a secure environment that the developers can tweak this code and build off of. That puts that far, far to the left, to the point where if developers are using this thing that security provided them already, there might not be any need for the security team to sign off on it, especially if you're using some of those automated security tools later on in the pipeline. You might have removed the whole security bit off of the change approval board's checklist just by virtue of having done that. One more thing that we're also noticing a lot more mature organizations doing is getting away from QA teams as we know them from the past. So QA generally refers to quality assurance. We still want that quality in place, but a lot of organizations are now moving towards quality engineers. So what I've done here in this particular slide is change one of these branches to be red. And in essence, we can say that this could be a quality engineer who is part of the team. They're not their own separate QA team testing things after the fact anymore. If they are baked into your delivery team, things that they can do is build automated tests using some of those tools we were talking about earlier. And if they are a little separate from the developers, there's a good chance you can get buy-in from your change approval board that with them building these automated tests, that it's not a developer who wrote the test, but it is a member of what we know in the normal sense to be a QA person creating these tests. As long as it's automated, it can be part of this pipeline and executed far earlier in the whole process. So as developers are integrating their code through the continuous integration process, we know that the test that the QA team have built out their test cases for, and to the best of their know-how, it is what needs to happen to ensure the quality of this application. If that's being executed automatically and it passes that, why can't we just tell the change approval board right then and there that, yes, this item has been checked off. The QA team has approved it. Getting all these things shifted left and automated is going to help you expedite this whole flow and get these hypotheses out into your end users' hands far faster and cheaper than ever before. Which brings us to this next slide. So the cost of not shifting left. If we think about like what I was just talking about with the QA team or security team, if we keep them further to the right, let's say the developers have already worked on things to the best of their know-how, things are great, and we send it through this whole deployment process and it gets to these later steps. The cost of finding issues there and bringing it back to the start far outweigh in a negative way the process of getting these things figured out sooner rather than later. So the better off and the quicker you are at getting these things shifted left to where it's part of this automated process, to where you aren't waiting on the security team's queue of, yeah, we'll scan your thing in 2 weeks from now, 3 weeks from now, or the QA team being a separate entity that happens after the fact. Any of these things that you can eliminate as these manual processes and shift to the left, that's going to help get your application out there sooner and faster. And additionally, it might help you get rid of that change approval board, which is, I'm probably speaking for a lot of people here, but it's probably everybody's nightmare, and it adds to that delay, as Matt was talking about at the beginning of this webinar, of experimenting and testing out these hypotheses that you as a product owner are coming up with.
So now, I know Ryan's given you an overview of exactly what a CI/CD pipeline does and what the value of it is. You're probably thinking to yourself, well, I signed up for this webinar because I'm a product owner, I'm a product manager. This is all great, but where do I fit in? How do I leverage this to be able to increase value and increase speed to production? And so we kind of came up with 3 ways to help deliver that value faster. And it's about getting smaller, becoming a scientist, and making the right investments in your CI/CD pipeline. So first, let's talk about getting smaller. So with the CI/CD pipeline in place, product owners can and should be making their asks of the team that much smaller. Now that you can safely deploy as fast as several times a day, Giving teams user stories that are going to take 2 weeks to complete just means it's that much longer before you can get feedback. And it's that much longer before you can then inform what your next decisions are going to be. And so we want to make sure that we're making our asks of the teams that much smaller and starting to scope smaller user stories so that I can get that smaller user story out and into production faster and get the feedback on it so that I can use that data and that information to make my next decision. And another part of that is not just by making your story smaller, but you need to make sure as a product owner, you're available to give more frequent feedback. If you're waiting till the end of a sprint and waiting till a demo to see some of the things that your team has built for the first time, you're actually delaying the ability to get that feedback. We ought to be in a place where as soon as the developer is done with it, that a product owner should be able to give that feedback, should be able to buy off the team's work, and then now leveraging the CI/CD pipeline, get that code out into production that much faster. If you've taken any class from us here at Sketch, you definitely tell that we preach the value of small batch sizes. Small batch sizes provide 2 different levels of value. So one, small batches go through systems faster. So whenever we talk about just in terms of getting things from point A to point B to point C, the smaller the batch size and the smaller amount and the smaller the feature that you're trying to move in through this pipeline, the faster that you're going to get that thing out to production. Also, a smaller batch size is going to give you lower variation. Just by virtue of it being a smaller amount of work, there's fewer things that can go wrong. It's much easier to debug a couple of days worth of code or a day's worth of code if you've got a problem, figure out where the problem is, than it is to try to debug a month's worth of code. The problem is small batch sizes aren't always economical. I've worked with teams before in the past where fixed costs of their deployment meant that it takes them this long to deploy to QA, it takes them this long to deploy to production. They've got to do all these checks, fill out this paperwork. I had a team that was delivering to production every 3 weeks. And the manager said, I'd really like to get that down to 2 weeks. Well, it ended up taking them about 3 days of fixed costs just to get it shipped out the door. I honestly can't advocate pushing this any further, because if it takes those fixed costs are going to take you that long every time, then you're actually starting to erode at the amount of time that it's going to take you to get work done. So it kind of in that case behooved them to have larger batch, because batches are actually a function of holding cost versus your transaction cost. Holding cost being the amount of time, the amount of value that starts to erode by not getting something into production. And that's usually something that we're not able to actually manipulate. But a CI/CD pipeline, having that in place, lets us lower the transaction cost and make it cheaper to go to production every time. And so now when we've made it cheaper to go to production, and it costs us the same whether we're deploying every day versus we were deploying once a week or once a month, now we are incentivized to be able to deploy that much faster because we've lowered that transaction cost and made it actually affordable to be able to deploy at a much more frequent basis. Becoming a scientist. This is kind of coming back to what I said at the beginning about everything being a hypothesis. You need to treat every new feature that you develop like it's a science experiment. You don't want to assume that whatever you're building is going to bring that intended value. And so you want to be able to get these experiments done and get these experiments done quickly so that they can inform the next decisions that you make. A lot of times when we're in situations where we can't deploy or once or even once a quarter, that I'm making decisions without the feedback from the previous thing that we just developed. A good friend of mine is a long distance rifle shooter, and he uses a spotter to help give him instant feedback of how off the target he is. Imagine if he was trying to do that without any feedback. Rarely do we have the absence of feedback, but is it timely? Imagine 2 more shots before he got feedback on the first shot. This, excuse me, this happens to us, and it can feel like we're making business decisions in a vacuum. So we don't want to let a lot of time pass between when we run our experiment and when we get our results, because there is time decay of that feedback. The longer it takes me to get that feedback, it may or may not be as it was earlier in the process. We want to make sure we're getting that feedback as quick as possible with these smaller experiments. So a lot of you are probably familiar with the concept of the minimum viable product, or MVP. And one of the things that I like to look at with an MVP is a lot of people talk about it in terms of it's the minimum amount of work or minimum amount of a feature that you have to have in order for it to be viable and usable. But I still encounter a lot of organizations that say, oh, that means I've got to have everything and it's all got to be there. Well, what I like to try to couch this is what is the minimum amount of effort you can put in to validate your hypothesis? Because you want to make those MVPs small. I still see people that try to scope MVPs that are going to take a month or two to develop. Well, that's not really an MVP, because that's a month or two without feedback of whether I'm developing the right thing or getting or on the right track. So the bigger your MVP is, the longer it's going to take you to build, the longer it's going to take you to get any feedback, and the less clear your result is, because you're going to have more variables at play. Like when I was talking about the science fair experiments that you would do, you'd always usually pick one variable. You'd have your constants, and you'd have one thing that you're going to change and see if that affected your hypothesis or not. Well, if I'm talking about pushing a month's worth of code to production at one time, there's way more variables at play. And so it might not be that I thought I'm pulling on this lever to make this enhancement, but maybe it was this other thing that I did that actually proved whether it was right or wrong. And I don't know unless I'm making things small, isolating those variables, getting that feedback, and then letting that inform the next decision that I'm going to make. So with hypothesis-driven development, it's just like going back to that science fair project, and we believe that this capability we're developing is going to result in this outcome. And this is the key: is we'll know we've succeeded when we see some sort of a measurable signal. This is the part that I see a lot of product organizations miss. It's we believe that we were going to deliver this capability, but at no point do we ever go back and validate that it's save us the things that we thought it was going to save us. So before we need a signal that's going to tell us whether we're on the right thing. Cycles. These shorter feedback cycles give us faster hypothesis validation, and that better data to make data-driven decisions with, as opposed to taking those shots in the dark without getting that feedback. So now it's all about making the right investment. If you have this, if you've already got a CI/CD pipeline in place, great. Now you've got new ways and new ideas on how you can leverage it to create more value. But if you don't, it starts with making the right investment. First, you have to figure out what is the return on this. And when you talk about what the return is, think about, really get into the nitty gritty and think about how much waiting is involved in that process. Like when Ryan had that big diagram that showed all the hops that I have to make in order to get something out to production, how much waiting is involved in the process? How much waste is there in the process? How much longer is it taking me to deliver these features over time? How much revenue is lost because these features haven't been shipped? Think of those things and start to calculate what that return might be, because a lot of these things we know are time sensitive. There is a decay to value. What might be a good idea today might not be a good idea a couple months from now. So you want to be able to get this in and capitalize on this as soon as possible. So start figuring out what are the gains that we could get by reducing the waste and reducing the waiting when it comes to getting our code shipped and out the door. Now start to figure out what's the effort. What's it going to take to figure out, put this pipeline together? To reduce the amount of time you're spending on building new features that you might not need, this is going to start to pay for itself over time, because you're going to be able to learn so much faster. But not getting those learnings incorporated in there, then we're not able to figure this out. So we want to make sure that we're taking the opportunity to invest in retooling. I like the analogy that I've heard where they talk about, a good craftsman, always invest time in sharpening a saw. A lot of times when our organizations were so concerned with getting the next feature out and getting these things out the door and pushing, that we never take the time to retool. We never take the time to sharpen our saws to make sure that we've got the right things available to us to be able to produce the best products possible. So we want to make sure that we're figuring out roughly how long this is going to cost, what this is going to take, how much time is going to be involved in this to figure out what is the cost of putting together this pipeline. And finally, what's important is that we've got to be able to prioritize it. We've got to make sure that this work is getting done. And it's good to be able to start to get these things into your backlog. But what's even better is starting to make these activities be a part of your daily work and be a part of that your daily habits and that higher level of craftsmanship. It gets to the point where I'm not putting in stories to go write automated tests. It's that it is a given and now part of our definition of done that providing this user story and developing it, what goes along with that is me writing automated tests, and goes along with it quality scans, and goes along with it doing all these things. And you want to start wrapping that up into your definition of done, so that now that becomes integrated into your everyday work. So we talked about that acknowledging that everything that you're going to be building is a hypothesis, and that the only way to be able to build the right stuff and know when the right time to build the right stuff is to be able to get the right feedback. And Ryan took you through CI/CD Pipeline 101 and showed you exactly how these things are working at a high level and what value they're returning. And then we kind of summed it up with talking about these important things about being about making your work smaller, being inquisitive, being a scientist, treating everything like an experiment, and then prioritizing and sharpening the saw in order to be able to tool yourself to be able to build the right things at the right time. So with that, we are going to open ourselves up for questions. And so we've got
two out there on the Slido, however you say it, already. So for those of you who might have joined late, we've got up on the screen here the URL to, you say Slido, right?
I say it.
I don't.
Slido,
I say
Slido.
whatever. That plays. Go to that URL, and then it'll ask you for a question code, Q&A entry code, and feel free to add questions if you want. But like I said, we've got two in here at the moment. The one that's rated first, I think this might be a good one for Matt to answer, but let me read this. So Anonymous asks, should creating test cases, or at a minimum, defining them with the test plan, be prior to any building? I definitely have an opinion, but I want to hear yours first.
So what I like to tell teams to do is, as we're scoping the user story and taking a look at it for the first time, that we at least want to have an idea of how we're going to test something. We might not have the exact test plan worked out. It's a little bit easier if we're talking about a bug. There's a lot of people have different opinions on where TDD kind of falls in, and where one place where I won't usually advocate test-driven development all the time, with the exception of bug fixes. If we're doing a bug fix, then we probably should have exactly how to test this outlined ahead of time, because we should have an idea of, we know how it's failing, we know how it should be working, that it's much easier to create that test that we know is going to be failing and code to getting that test to passing.
I couldn't have said it any better. I think I'm just gonna hold my opinion because you pretty much said it all. We got a couple more questions coming in, which is great. Let's go to the next one though. It says, does this process look different if you are developing an AI ML as opposed to an app? And second part is, how does CI/CD apply to advanced analytics use cases? So definitely the pipeline's going to look a little different. And when we are on that crazy slide that I spent maybe too long talking about, if you remember, there are some intersections and blurred lines that we were talking about, and that's because not every single organization does stuff the same way. Not every application is the same type of application. So there are definitely nuances from app to app, and you might have different steps from one to the next in your pipeline. So for artificial intelligence, machine learning kind of things, you probably aren't going to have that security scan phase. You probably aren't going to have a change approval board phase. You probably aren't going to have some of those bits and pieces, and they're probably not database, or you may or may not have database schema changes depending on the nature of that machine learning thing that you're working on. So it could definitely be different, but I think the overarching point that I definitely want to make with that whole thing is automating every step of the way is the key thing to focus on. So if your pipeline has 3 steps, that's fine. As long as you can get it automated, that's great. Chances are though, with things like a machine learning model that you're working on, your test cases in essence are those different positive and negative results that you're giving it. So you're giving the computer, you're giving them thousands and thousands and thousands and thousands of these things, saying, I want you, computer, to learn that this is the wrong way to do this, and these other ones are the right way. So you are building those test cases. And while a developer might want to do some of that computation or compilation of the actual machine learning model locally, having them do that with that whole data set is probably going to blow their computer up. It's probably more than it can handle. So having the full set of those learning entities in there that would be something you want as part of the pipeline. And that's something you should automate. So as a developer is working on things, tweaking the algorithm a little bit, when they commit that algorithm change and merge that into the main branch of code, the pipeline's going to take it, run the full suite against it, and then have a more polished algorithm as the output of that. So you can definitely have the pipeline still, but totally the steps are going to look different from that sort of application to the next. Something to keep in mind, though, is having an algorithm out there just for the sake of having the algorithm probably isn't super fruitful. You probably, within your organization, have maybe another team building an application that implements said algorithm. Their pipeline might look a little more similar to this. So the nature of anybody's pipeline is going to be different from app to app or organization to organization. There really never is a one size fits all that you can do company-wide, especially if you have a ginormous global company. We've seen organizations try to do that before, and it gets a little cumbersome, and a lot of the delivery teams start to get handcuffed because the pipeline isn't quite as robust as they need it for their app, and or requesting changes because it's controlled at a central level of the whole global organization. Requesting changes becomes painful for that central entity to do because it might impact everybody else that's using this centrally managed pipeline. And it can really delay you as a product owner getting these changes out there if your developers can't leverage the pipeline the way they need it to run for their particular app.
So I want to jump down and take the next one here about how is manual testing integrated into the CI/CD pipeline? Is UAT essentially done post deployment? So one of the things that you're going to have to that makes this work, and this comes right back to how a product owner operates, is here at Sketch we say that a product owner needs to use the acronym CAT to determine what a product owner needs to have in order to be successful in their role, and they need to have curiosity, authority, and time. And one of the keys there is that authority. They need to be able to buy off the work that the development team does. If I have to go to some outside person or outside group to do some sort of user acceptance testing, that creates that delay and this whole thing starts to fall apart. If it's I've got my code done, product owner thinks it's great, but I've got to go wait for somebody else to do user acceptance testing. Now we're all sitting waiting for that feedback in order to get it out into production, to be able to get the code shipped and to be able to get the next level of feedback. So what we really aim to have is we don't want to do away with all manual testing. I still like to have QA people being able to do exploratory testing, being able to do things that are outside of the normal test cases, being able to find things that we wouldn't normally find. And that's that's great about automating the test cases and the things that we know about, is it now frees up QA people to do testing for things that are more unknown. But when it comes to customer acceptance testing or user acceptance testing, we really want to be able to shift that authority to be at the product owner level, so that the product owner can be able to say, yes, this is good, ship it, which is another reason why we don't want to wait till the demo for the product owner to see it. As a developer, if I'm done with the code, it's checked in, it's been deployed up to a QA environment, I want to be able to demonstrate that to the product owner, get their validation that says, yep, that's good, so we can check that box and get it shipped through the next part of the pipeline. I don't want to have to wait days or weeks, or I've seen cases where I've seen teams that have had to wait months to get the right level of customer acceptance to be able to ship something out. And we don't want to be able to see that in order to get things out the door and get that fast feedback.
Okay, we're getting short on time, so I think there's a couple questions we should, I don't mean to rush through, but we should definitely get to all of them. A couple things that have been asked by a few people are, can we have the slide deck? Yes, we can definitely send that out. We're also recording this webinar, so we'll send everybody a link, maybe in another day or two or something, with the recording of this webinar. I do want to address this one. It just got bumped up. Somebody upvoted this thing. So what kind of operational overhead or expertise is required for these additional pieces of automation software? It definitely depends on what types of tools you integrate with. Some of these have pretty much straight out of the box. You can just launch this thing and have it up and running. And as long as it's, I mean, we could get in a lot of detail, and I feel like I'm going to head down this rabbit hole, and so I shouldn't. But let's just say there's no reason a developer can't launch this themselves locally, and if they're capable of doing this locally, because a lot of these tools have the quick, short, and sweet. Here's how you get this up and running. Because keep in mind, these tools, there are thousands of these tools out there, and each one wants to entice you to use theirs. So they want to make it as easy as possible to integrate with, to get you up and running as fast as possible. They're not making these things impossible for everybody to use. So there doesn't need to be a lot of operational overhead, although depending upon the nature of some of your regulatory compliances, there might be certain requirements for backing up the results of a lot of these. More often than not, though, the way I like to think of things, I try to keep things as simple as possible. So I don't focus on the fully robust version of these tools. And I don't care if I lose my historical results a lot of times. A lot of times it's more of a stop gate as to whether or not my latest changes are allowed to go through or not. I don't really care, did my changes from 6 months ago not go through? So it depends on how much of a need you have for something like that. Do you need to worry about more of that operational overhead? A lot of times though, you can have it up and running, and if you're okay that it, maybe crashes once a month and you just click the reboot on the thing and gets you up and running, that's totally doable, especially if your dev team is in charge of it.
Yeah, and we talked earlier about oversimplifying things, and one of the things Ryan likes to say when we teach our DevOps bootcamp is tools, those CI/CD orchestration tools like Jenkins that are out there, they're really more just like glorified cron jobs. And really, if you've got a high-level understanding of shell scripting, using these tools, you can probably get by and start to put together a CI/CD pipeline pretty quickly. And so you can always definitely go deeper down the rabbit hole. But really, if you've got an idea about how to be able to create shell scripts to be able to move this, copy that, deploy this, that those orchestration tools make it really easy to execute those types of scripts.
Okay, I want to hit this one real fast, and then there's a great one for you. So you read that while I'm answering this one. Okay, so there's a follow-up question to one that I think Matt was answering earlier. And I do have a great opinion on this one. Pat myself on the back. Yeah, it's a great opinion. Is UAT essentially done post-deployment? So one thing that we talked about a little bit earlier on is the difference between continuous delivery and continuous deployment. We didn't get in a lot of detail on that one. Definitely look at Sketch's website for references to more boot camps, trainings, and blog posts about this topic. But you can leverage different concepts like feature toggling or blue-green deployments so that the UAT testing can happen in your staged production environment prior to flipping that delivery switch. So you can do the deployment, but deliver it later. You can deploy to whatever environment, do a little smoke testing, and then flip that switch for the delivery. That's the distinction between deployment and delivery. We've got lots of other talks and we can get in more detail, but feel free to reach out to us afterwards because we're definitely running out of time. Matt, I wanted you to hit that one.
Yeah, so the next question is, what if you know functionality is definitely needed for your app? Should we strive for smaller stories, or is it fine to follow the preference of your devs? I would still strive for smaller stories, because even if it's a piece of functionality that you absolutely know is going to be needed, there's still going to be subtle nuances to it that you might not know, oh, it also needs to do this, or it doesn't need to do that, or, oh, I delivered this thing that absolutely works, but I didn't know it might break something else down the road. The smaller the batch size that you've got, like I said earlier, the fewer things that can go wrong and the less variability you've got. So I would still strive to have smaller stories, because I've had stuff that has gone in and then has worked perfectly fine, but we find out later broke something else. If I'm doing that in a small batch, it's much easier to figure out when we find that something else is broke. We know we've only made these small incremental changes and can you more easily figure out where we broke that thing and be able to make that kind of and to be able to get the fix in quicker than you'd get that from working in smaller batches.
Okay, we've got one last question, I think, remaining to answer here. The question is, could this be done on a smaller scale or without additional software? Any thoughts on employees' fears of obsolescence or being replaced with automated processes?
I'll take the second part of that question.
Perfect, good, because I want the first one. So yes, definitely pipelines are a growing organic thing. Sketch gets involved with a handful of development engagements here and there where we like to act as one of those garage band startup kind of companies to get stuff out fast. And that's sometimes the engagements specifically call for that. The client might want this thing in a super short and tight timeline. So as I was mentioning earlier, these pipelines take the developers' hands off of these manual deployment processes and keep them focused on delivering new features, new functionality. So what we like to do in those types of engagements that we get called into is build a pipeline that maybe has 2 steps, 3 steps. After the developers have merged their code, it's going to run the automated unit tests and then deploy it. So it's that simple. And a lot of times, because these are startup type applications, there's not necessarily a production environment until maybe 6 months out, 12 months out, whatever. We don't necessarily need to worry about security up front, but the sooner we can get that pipeline, that small scale pipeline, that's all it does is run the test, make sure you didn't break something that your neighboring buddy just worked on. And if all those tests pass, then launch it to prod. Then as we start building more features, we'll find time to bake into enhancing the robustness of the pipeline. We'll add some of those security steps to it later. We'll add some of the quality scan steps later. You don't have to have everything up front, but if you can get just this basic minimal pipeline out there to get your developers focusing on building new experiments, building new features, testing your hypotheses, this is going to help get your ROI a lot faster.
And so to the second part of that question about any thoughts on employees' fears of obsolescence or being replaced by an automated process, computers are great at taking orders and carrying out those orders. People are great at using their big, beautiful brains for creative problem solving. And what we want to be able to do is take all the repetitive tasks that a computer could do and that you could automate and get those off the plates of people, so that people can start to use their brains for creative problem solving. Like, I'll never forget, it was one of the big cases for doing database automation at an organization I was working with, where their DBAs, they were strapped for DBAs. They only had, a handful of them in this huge, this huge organization. And they were spending all of their time working tickets, taking in requests to just deploy this table, execute this script to deploy this table, or create this package or procedure. And they just spent their whole day executing scripts. And then one of my teams that I was working with was stuck on a problem on a performance issue, and they needed help doing some tuning. Well, the DBAs weren't available to go help with anything like that because they were having to spend their day working these tickets. If all of those things that the DBAs were doing in terms of just executing scripts to deploy tables and packages and procedures, if we could automate all that stuff, now we can pull the DBAs back out and and you have their time be allocated to creative problem solving. And that's what we want to be able to do across the board with any of these things that we're automating. I don't want to not have an ops engineer. I want to have an ops engineer now not having to deal with how I'm applying these patches or doing these things, or all these things that are in automated fashion. I want them to be thinking about other stuff, thinking about what are things that could go wrong, other things, and start to have that more creative problem solving take to what they're working on. I think that's about all the time we've got.
Yeah, we're out of time, and that was all the questions. So
Perfect.
Thank you, everybody, for your time. We definitely appreciated having you join us for this webinar. Once again, I'm Ryan.
And I'm Matt.
And this was a sketch webinar about what a CI/CD pipeline can do for you, the product owner. Thanks
Thank-
again.
Thanks, guys.